Here we go with fourth grade lesson 100. We're into the triple digits now. Lesson 100, we're going to be comparing decimals. Greater than, less than, etc., etc. Comparing decimals. When comparing decimal numbers, use the same procedure you have been using when you compare non-decimal numbers. Right? With the digits, start with the digits in the furthest to the left in each number, but they have to be in the same place value, and compare the values in each place. We'll go over this. So when you are comparing decimal numbers, it might be help to add zeros so the numbers have the same number of decimal places. To change the decimal numbers to mixed numbers with the same denominator for the fractions. So here we go. The way we do this, 3.2 compared to 3.18. Now, some people are going to think this number is bigger because it's got 18 there. It's only got 20 there. Well, 3.2 is the same thing as 3.20. Think like money, okay? So this would be like $3.20, right? You got to have, you should put two numbers after the decimal point there, and then two numbers after the decimal point here, so that both numbers have two numbers after the decimal point. So now you can see $3.20 and $3.18. Clearly the 320 is larger, but if you take that zero off, it could be kind of tricky. And 20.20 means 20 hundredths, and this is 3 and 18 hundredths right there. By changing them both to decimal numbers with the same number of places, or to mixed numbers with the same denominator for the fractions, they are easier to compare. All right, let's move along here. So we are going to put a greater than or less than or equal to sign here. We've got 4 compared to 4.02. Well, this one should be pretty easy because 4.02 has some extra stuff on it compared to the number 4. This is the number 4, or 4.0, and here's 4.02, right? So the extra stuff on this number makes it worth more. Can you put the symbol in there before I tell you? All right, so you should have written that because 4.02 is bigger than 4. All right, the next one has 5.3 and 5.30. Go ahead and add a 0 in to make both numbers have the same number of digits. So here we have, you should already do this. You should put a 0 like right here, okay? So now you have 5.30 and 5.30. Well, those are the same number. You should put an equal sign in there. All right, pause the video, try number 3, and then turn the video back on. 7.58 compared to 7.4. Put a 0 so that they both have two numbers after, two digits after the decimal point. So we have 7.58 and 7.40. 58 is bigger than 40, or 58 hundredths. This is 58 hundredths. 7 and 58 hundredths, 7 and 40 hundredths. Obviously, 58 is bigger than 40. All right, why don't you pause the video and do all of these, 4 through 9, and then turn the video back on. So we have, you should have already done this, 6 and 6. Those are equal to each other. You could put 6.00 there, 3.9 and 3.09. Well, if we put a 0 there to make it have the same number of digits, because there's no hundredths place, there's only tenths place in the 3.9, that's like $3.90 compared to $3.09. 390 is the bigger one. 2.17 compared to 2.70. You should have put a 0 right there. 2.70 is bigger. And then again, put a 0 in on this one here. We got 4.36, 4 and 36 hundredths. 4.40, 40 hundredths. And 40 is bigger than 36. 8.39, 8.29, nothing to do on this one. 39 is bigger than 29. And then here we've got 7.10 and 7.1. Well, 10 is bigger than 1. So that one is the larger number, like $7.10 compared to $7.01. Okay, now we're going to do the same idea here, except we're going to be looking for the number that fits in the blank. So here's 4.82, the number 3. Notice where the comma is there. 2.9, 3.04, and 4.7. If 3 is the big number, which number up there is the little number? 2.9 is smaller than 3.0, or 2.90 is smaller. So that number goes in there. All right, why don't you try number 11? Pause the video and then turn it back on. 2.4 here is the big number. We're looking for the little number here. Well, 2.4 is like 2.40. You should probably fill in a 0 and any numbers that have, don't have two numbers after the decimal point. And the number up here that's smaller, well, 4 is bigger than 2. 2.43, that's pretty close. 3 is bigger than 2, so it can't be that one. 3 is bigger than 2, and then you have 2.34. Well, 2.43 is bigger than 2.34, and 2.43 is bigger than 2.40. So 2.34 is going to be our smaller number compared to 2.40. How'd you do? Did you get that one right? All right, pause the video, do 12 through 15. Go all the way through 15. Turn it back on when you're ready to see the answers. 7.19 is the small number. We're looking for the bigger number here, so it's got to be 7 point something. All these, look at 3 point something, 5 point something, 3 points. The only one that's going to be bigger, 7.5. And again, 7.50 is bigger than 7.19. All right, 6.0 is the little number compared to the big number. It's got to be bigger than 6. That's equal to 6, but that's 6 and some extra. 6.26, 6 and 26 hundredths. This is more than 6. 7.08 is the big number. We got to find the little number here. And 7.1 is like 7.10. That's actually bigger than that. 7.83 is also larger because 83 is bigger than 80. 7.53 is also larger than that one. And 7.09 is also larger. So, oh, I skipped one. I'm like, wait a minute, none of these are right. 7. 7 is the smaller one. 7 is smaller than 7.08. Okay, number 15. 5.84 is the small number. We're looking for the big number. 5.93 would be bigger than 5.84. Pause the video, and I want you to do this box down here and the box down there. Do both of those boxes, and then turn the video back on to see the answers. All right, so here we have 7.83 as the little number. The big number is 9.38. That's pretty easy. 3.52 is the big number, so we need the little number. This is 3.50, right, which is smaller than 3.52. And add those up in the corner over there. Make sure you did the check answer. And then down here, we've got 7.8. Which statements are true? 7.8 is equal to 7.08? That's not true. No, because this is 7.80. 4 is smaller than 4? No, not true. 2 is big and 0.8 is small? Well, yes, because this is 2.0 and this is 0.8. So that's a little bit of a tricky one, but 2 is bigger than 8/10. So that one is one of our true ones. 3.5 is bigger than 2.0. Yes, that is true. 3.72 is bigger than 3.59. Better believe it, because 72 is bigger than 59. 5 is not equal to 5. Oh, by the way, this is true. Put those letters on there. You should always put the letters. 5 is not equal to 5. Oh, no, those are equal to each other. So we're not going to pick that one. And we're going to add up 7, 4, and 6, which equals 17. All right, there you go.